Now here we shall understand about the cleaning operation of a slow sand filter. As the process of filtration goes on, the filtering media gets clogged due to the impurities adhered to those sand particles, and the loss of it will go on increasing gradually. When the loss of it reaches certain limit, the working of filter will be stopped, and at that time the filter requires cleaning. So it may also be noted here that the water entering the slow sand filter should not be treated by coagulants. This is because the fact that the dirty skin or smooth deck formed by the flock is carried to the filter considerably, thereby affecting the economical working of the filter. The depth of water on the filter should also be decided carefully, and it should not be allowed to undergo large variations. This depth decided should neither be too large nor it should be too small, and generally it is kept equal to the depth of the filter sand. The loss of head, called as filter head or filtration head, is generally limited to a maximum value of about zero point 0.7 to 1.2 meter. And when this limiting value, which is roughly kept around zero point 0.7 to zero point 0.8 times the depth of the filter sand, is reached, the filter unit must be put out of the service and the filter needs cleaning. The cleaning of slow sand filters is not done by backwashing as it is done in case of rapid gravity filters, but it is done by scraping and removing the top layer, that is around 1.5 to 3 centimeter of the top sand layer. The top surface is finally raked, roughened, cleaned and washed with good water. The amount of wash water required is generally very small, say of the order of zero point 0.2 to 0.6% of the total water filtered. Cleaning will be repeated as and when required, that is until the sand depth is reduced to about 40 centimeter or so. Then more sand is added, that is upon the reduction of the sand layer after scraping. A lot of manual labor is required in cleaning of slow sand filter, although very small quantities of wash water are needed. After each cleaning, the filter is again used and the raw water is admitted into it. But the effluents that will be obtained in the beginning will not be as pure and are not used for about 24 to 36 hours until the formation of the dirty skin or smooth deck for arresting impurities around the sand grains. The interval between the two successive cleanings of slow sand filter depends mainly on the nature of impurities present in the water arrived from the previous unit and also on the size of the filtering sand used in the filter. This interval, however, normally ranges between 1 to 3 months. So next is about the rate of filtration of slow sand filters. The rate of filtration is very low. It is generally 100 liters to 200 liters per hour per square meter of surface area of the filter. Now about the efficiency and performance of slow sand filters. Slow sand filters are highly efficient in removing bacteria. This is because of the slower rate of filtration and other suspended solids that is been from the previous units. The extent of bacteria removal is up to 99% or even more. These filters will also remove the odor and taste, particularly those caused by the presence of organic impurities such as those from algae and planktons. But however, these filters are less efficient in removing colors of raw waters. These can remove turbidity up to 50 NTU and are not suitable for sedimented waters which have the turbidity greater than 50 or 60 NTU. So now how about the uses of slow sand filters? They are best suited for smaller plants and for purifying waters with low color, low turbidity and low bacterial content. However, because of their smaller rate of filtration, they require huge surface area and large volumes of filtering materials, which makes them costly and uneconomical, especially for treating large scale supplies. They are therefore being replaced by rapid gravity filters at major cities and towns. They may, however, be preferred for smaller plants, that is, in case of village supplies, or for individual industrial supplies, especially in humid and underdeveloped countries like India. It is observed that the rate of infiltration is more in coarser sand than that in finer sand. So, the theory of rapid sand filter or rapid gravity filter is based on the principle of increasing the rate of filtration by providing coarser sand as the filter media. The filtration head is also increased to increase the pressure head and the rate of filtration, which was lacking in case of slow sand filter. We have seen in slow sand filter that the rate of filtration was very low and it was requiring more space for installation. To overcome these difficulties, the fine sand in slow sand filter is replaced by coarse sand to achieve greater percolation and to reduce the surface area. The rapid sand filters are of two types, one which utilizes comparatively larger size sand particles which will allow greater rate of filtration in comparison to that of slow sand filters, and they are called as rapid gravity filters, and the other which utilize the development of pressure over the filtering water and thereby increasing the rate of filtration, which are called as pressure filters. Rapid gravity filters are usually used for larger municipal supplies, whereas pressure filters being more handy and can be used for smaller installations such as for industrial plants and swimming pools. A typical section of a rapid gravity filter is as shown here in the figure. The various parts of the rapid gravity filters are the enclosure tank. So here we can just see the enclosure tank. It consists of an open watertight rectangular tank made of masonry or concrete. The depth of the tank may vary from 2.5 to 3.5 meter. In order to achieve uniform distribution of water, the area of the filter unit should not be kept larger and is generally limited to about 10 to 80 meters square for each unit. The number of units at a filter plant will be roughly estimated by the equation developed by Morel and Wallace. There should be at least two filter units in any plant wherein these type of filters are installed, and for a plant of more than 9 MLD capacity, no single unit should have a capacity greater than one-fourth of the capacity of that plant. Coming about the under drainage system, the figure shows the under drainage system of a rapid sand filter. The under drainage system consists of a central drain and a perforated lateral drains. The lateral drains are connected to the central drain from both sides and they are placed at a distance of 30 centimeters center to center. Generally, galvanized iron pipes of required diameter are used in under drainage system. Now moving on to the base materials, clean gravel of different size are used as base materials for the supporting. These gravels are placed on the under drainage system in four layers, each layer being 15 centimeter thick. The bottom layer is made of bigger size gravel ranging around 20 to 40 millimeter. Two intermediate layers are provided. In the first layer, the gravel size is 12 to 20 mm and in the second layer it is 6 to 12 mm. The top layer is made of smaller size gravels around 3 to 6 mm. The coarse sand of effective size of 0.35 to 0.65 mm and uniformity coefficient 1.2 to 1.8 is generally preferred as the filtering media, and the depth of the sand layer varies from 60 to 100 centimeter. Moving on to the other appurtenances used in the rapid gravity filter, it is the air compressor. It is provided for sending the compressed air through the under drainage system at the time of washing the filter. Troughs, These are provided on the top of the sand layer for carrying dirty water at the time of washing the filter. The next one is the rate control. This is provided to control the rate of flow. There are other miscellaneous accessories besides all these appurtenances, and they are head loss indicator, and it is nothing but a differential type of a mercury gauge, one end of which is connected to the water that is resting on the sand bed and the other to the effluent coming from the filter. Arrangement can also be made for recording the reading on a time scale. Meters are also installed for measuring discharges at entry and the outlet and also at backwash. So here from the picture we can understand that there is a rectangular enclosure tank which suffices various appurtenances as discussed previously. So in normal working condition, the valves V1 and V2 are kept open and the other valves are kept closed. The water from the coagulation tank enters the inlet chamber through the inlet pipe. Then the water is uniformly spread over the entire chamber through the inlet pipe. Then the water uniformly spreads over the filter media. The filtered water is collected in the central drain through the lateral drains. Finally, the water is taken to the storage reservoir. When loss of head exceeds some limit, then a negative edge is formed, and at this time the function of the filter is stopped. This means that the filter requires the washing so as to resume its normal working condition. So now let us understand about the very important concept of the rapid gravity filter, that is the cleaning of the filter, what we call as backwashing. When some sand becomes dirty, which is indicated by the excess loss of head, the filter must be cleaned and washed. For cleaning, the raw water supplies as well as the filter supplies have to be cut off and the beds drained down, and the wash water which will be sent back upward to the filter beds has to be looked for carefully. This forced upward movement of wash water and compressed air, if and all it is used, will agitate the sand particles and thus remove the suspended impurities from it. Valve 1 and 4 are closed and valve 5 and 6 are open. The wash water and the compressed air are thus forced upward from the under drainage through the gravel and sand beds. Valve 5 is closed after supplying the required amount of air. The dirty water resulting from the washings overflows into the wash water troughs and is removed by opening the valve 2 through the inlet chamber into the wash water gutter. The process of washing the filters and removing the dirty water is continued for a period of 3 to 5 months. After the washing of the filter is completed, valve 2 and valve 6 will be closed and the valve 1 and 3 are open. This will restore the inlet supply through valve 1, but the filter water in the beginning is not collected and washed for few minutes through valve 3 to the gutter. This is necessary because the remaining of the wash water must be removed from the voids of the filter and surface must be allowed to be formed on sand. Ultimately, valve 3 is closed and valve 4 is open to get the filtered supplies again. The entire process of backwashing takes about 15 minutes and the filter unit remains out of operation for this much of time. The amount of wash water required for washing rapid gravity filter may vary from 2 to 5% of the total amount of water that is filtered, and the rapid gravity filters get clogged very frequently and have to be washed every 24 to 48 hours. The rate of washing may vary between 15 to 90 centimeter rise per minute. A figure of 45 centimeter per minute is quite acceptable, and this rate can be provided by a flow of 500 liters per meter square of bed area per minute. Normally, 10 to 15 minutes are required in washing, but in recommissioning, a total of about 30 minutes may be consumed, and the pressure at which wash water is supplied is about 40 kilonewton per meter square. We shall now understand